Hello everyone, and welcome to my channel and my videos in transportation engineering. Today, this video is related to my transportation engineering or introduction to transportation engineering class, CE331. It's for my students, but it's also welcome to everyone to watch this video. Today we're going to talk about a very important topic that's an intro to highway design. Again, this is intro to transportation engineering. We have transportation engineering topics, and one of the main topics of transportation engineering is to understand some of the highway design elements. So we're going to just grab some inputs that we will need for our highway design that are very, very important for our highway design, and let's start our video. So as you can see, we're going to talk today about some of the elements of highway design. So before we go, let me just remind you of our umbrella. So here, this is the umbrella that we call here, that we call here transportation. Let me just make it smaller. So this umbrella that we call here transportation. So transportation engineering is a very, very big topic. It's a topic that includes other topics under it. So I always call it the transportation umbrella. It's a vast and it's an interdisciplinary, and under it we have different topics. I'm just gonna highlight very few that was discussed in my class, but I just want to repeat that. Among that is what we're going to start today, which is highway design, or highways. Let's just put it highways. And highways include several things. How to do design, how to do maintenance, how to do construction. The highways is a great topic, a big topic that has lots of stuff. It's related to everything related to the highway that we drive in. It includes what we're going to be talking about today, which is geometric design. And geometric design is the design of anything related to the dimensions and distances and width and length of your highways, radiuses and curves and everything related to this highway. So you have, radius, not radiuses. And again, we have here pavement design. And pavement design is another huge topic by itself, and you can see everything is under the word transportation. Another topic that we also study a lot is traffic engineering, and traffic also, oh my god, it has several topics under it. Among that, we have something called ITS, Intelligent Transportation Systems, which is using technology to manage traffic. We have, let's say, traffic safety, and several others, simulation, and different things related to traffic on the road. There are other topics that we discussed in class. Let's also talk about, for example, fleet, or public transportation. So all these are topics that go under this transportation. This is what our class is about, is that we try to pick different topics, and we're going to pick all of these, introduction to all of these things in our class, and part of that is highway design. So again, we're going to talk today about highway design. When we talk about geometric design, we care about everything related to this road here that we drive at. The dimensions, when you look from this way, for example, cross-section, how many lanes you're going to have, what is the width of the lane. You have a sidewalk, you have a shoulder, you have drainage, you have a curve, what's the radius of that curve so you can have a safe drive. You have an intersection, what are the different radii of this intersection turns. You have a grades like we have in different states in the US. Do you have grades that go up and down? So how are you going to build this kind of curve that goes up and down? So we're going to also create that. Everything under that is called geometric design. It's a huge focus in our class, but again, it's a very easy and nice topic. It just borrows very few equations from geometry and from math, and we're going to use that in our work. So let's get back to our presentation. I'm going to get back and forth between my presentation and my whiteboard, and let's start. So as you know, guys, as you know everyone, that our road has, or any transportation system has, four elements. These four elements work together, and this creates the medium where we all walking, driving, biking, and we have these elements working together. So any transportation system in the world, whatever this transportation system is, has elements in it. If you talk about public transportation, you talk about trucks or freight, or we talk about whatever, it has these four things. So number one, it has the users, people who use it. So road users. Let's talk here about mainly passenger transportation. So we have here number one. Let me just bring my highlighter here. So we have here the road users. And if it's public transportation, it's the passengers. If it's freight, it's the truck drivers and the train drivers. So again, it's not only for highways, but we're gonna just focus a little bit on people moving of people from one place to another, like we discussed in our first introductory video, where we wanted to move people from one place to another. So it includes the following. It includes number one, the drivers, and I have some funny pictures here. The drivers who are distracted, who are have different attitudes. Number two, we have the pedestrians, people walking on the road, and these are passengers. So we have pedestrians, people walking on the road, like these guys here, crossing the road, walking on the sidewalks, walking on shoulders. We have cyclists. We have passengers in the bus and the subways and different parts of the public transportation system. And then we have the vehicles, that have different kinds of vehicles, motorcycles, buses, and different vehicles that take people from one place to another. And then these vehicles are on your roads. All these are roads, so it's streets and highways that we're gonna try to design and try to bring some input for the design. And finally, to make sure that people are moving safely and smoothly, we build all these transportation systems. So this is part of the streets and highways, but they are controlled by means of control devices. And this is part of traffic engineering that we mentioned a few minutes ago. So all these signs, signals, markings, technologies that we use to give information to the drivers, these are all called control devices. How can we control the traffic to avoid what you can see here, and avoid congestion, and to make your road safer, and also to avoid what we see here? How can we avoid this really bad scene here? So the components again: drivers, PEDs, vehicles, roadway. When we talk here about the highway system, the highways, we have the drivers, pedestrians, vehicles, roadway. Other components are in there, of course, but again, we want to focus on these four for our presentation today. These are the inputs that we use for design. So again, we talked in the previous slide about all the transportation system, what are the elements that go there. When we talk now about the highway design, drivers give us some inputs, pedestrian give us more inputs, vehicles and how the vehicles work and brake and turn give us some inputs, and finally the roadway also gives us some inputs, so we can design all these geometric elements. Also, sometimes, when we do our design, you can see that in different places where we have snow and ice, where we have lots of rain, when we have sand, when we have other environmental conditions that might affect the drive. So sometimes these also have some different numbers that enter into our work. For example, rain, snow, fog, dust storms, and any other environmental conditions or weather conditions that might be some kind of input in your, again, geometric design. You might see some signs in different countries when it says here, for example, fog, or slow down when you have snow, or icy conditions, to do what in icy conditions. So we have different, sometimes environmental options that will sometimes guide our design. I want to bring back this. We talked about this usually in statistics, but again, I will put it in very easy and straight words here. Is that any human-related criteria is something, any criteria, anything related to humans. For example, let's just put here some human characteristics. Your height, your weight, your IQ, your grades, your GPA, whatever related to humans is something in statistics. We need to collect data to figure out what's going on in all these stuff. Again, also in science, for example, reaction to vaccination, immunity, blood cells, whatever you are doing also in different human related conditions, it's all these characteristics follow what we call here random variables. And statistics here is the science that statistics is the science that tries to figure out these random variables. And we try to model them. We try to get data as much as you can. For example, we want the height of the whole people in one country, or the IQ of different people in university. So we collect data, we test them, and using the data, we try to figure out what's the value of random. And since they're random, they follow different distributions. Distributions are ways for us to model these really crazy random variables in a more systematic way using what we call here statistics. One of the most famous distributions, we use it in most of these human-related random variables, something called the normal curve. Again, this is a crash course in statistics. The normal curve is a curve that simply says the following: if I'm going to model this random variable, for example your height, and we found that the height, or let's say the IQ, that the average person in one country IQ is 105. And we counted how many people. Again, statistics here is the science of collecting data and counting. And we found that most of the people are around this 105. But however, you're going to find people who are smarter. So they go this way. But less people. So the curve that we try to model, we try to find the equation for that model, goes this way. Also, we have people who are less smart, have IQ less, but less people are like that. Most of the people are around it. Sometimes the distribution is different. It might follow a different distribution. But most of the random variables follow a distribution that goes around what we call here the mean value, which is the average of number of people. And you're going to find most of the people are around the average. We talk about, for example, height. Maybe, for example, in one country, most of the people are around 5'8". And you have people who are taller, basketball players, very, very tall people. We call sometimes, if there's a guy here, 8 feet, that's an outlier, meaning a person that's out of the normal. Or if you have short people, maybe 5'4", 5'3", and so on, less than 5, you have less people, and you have also some little bit of outliers who are probably very, very little according to the distribution of people. And this is what we call here a normal distribution. Let's get back to highway design. We're going to talk about two random variables. Number one, something called reaction time that we use to design all our highway components. Reaction time is also a value, and this value here is how much time people need to react if they find something while they drive. It also follows this kind of curve, so let's draw it again. So it's again a curve like that. You're going to find that, let's give it a number here, 2.2 seconds is the average random variable, the average value for action time for everyone in a group of people that we collected. Name the sample, and we say this sample should represent the whole people, the whole population of people. And you're going to find that also reaction time goes like this. when we count, so again, this is what we call here the frequency. How many people are in every value? You're going to find that most of the people around is 2.2. However, we have people who are very, very fast in their reaction time, but much, much less compared to the other population. For example, a baseball player, a goalkeeper, they have less reaction time, so they can excel in their sports. And we have people who are a little bit slower. When we want to pick up, and here comes what I want to reach here, is that when we want to pick up a number that will capture everyone in my driving population, I cannot have all these values. I cannot say, yeah, it's 100%. I will never reach a number. Should I make it 10 seconds? It will make the design of my highway really bad. So I pick something called 85th percentile. In other words, it's the value. Let's say it's 2.5. And that's the number used by Ashby. In which, if I use this number, 85%, it's the area under this curve now, 85% of the people will have a reaction time of 2.5 or less. Again, 85% of the whole population of people will have a reaction time of 2.5 or less. So in this case, when I say my reaction time, TR, is 2.5, I here captured everyone that is faster than that. They're taken care of. Yeah, there are some outliers here that I did not take care of. And here comes the police and the enforcement, where they try to make these people slow down a little bit. If they have really bad reaction time, and also licensing process that will handle these people who are kind of slower in their reaction time. And here comes the law of giving licenses to people. So this is called the 85 percentile. Another factor we're going to use also when we talk about pedestrians is walking speed. So what about walking speed? Well, it's also a random variable. So let's say that the average walking speed is 3.5 feet per second. 3.5. Again, some people are very slow. Kids, for example, older people, people with strollers. So you're going to find people who are very, very slow. But people who are very, very fast, for example, athletes, runners, soccer players, they are much, much faster when they walk. You're going to find also that most of the people are around this 3.5. But you have less people who are faster, and less people who are really, really faster here in this case, and less people who are slower in that case. When I want to find a number to design, for example, a push signal to figure out what's the speed of people crossing the road, so you can give them enough time to cross the road in the signal, we want a number slow enough to capture also 85% of the people. And 85% is a statistical value that tries as much as it can to capture. Again, I cannot capture everyone. I cannot say my speed is 1 feet per second. That's a turtle speed or turtle speed. So again, I cannot design it. It's going to drive my system crazy. So I say, yeah, I'm going to do here a value here. Let's say 2 feet per second, or 2.5 feet per second. Again, it's depending on my data. And the area from here up to infinity is taken care of now. So if a person is so fast, he's taken care of when he crosses the roads. A person who is slower, well, again, enforcement comes here, and sometimes you make me do this all. This value here, because it's on this side, it's called the 15th percentile. Again, it takes care. It means that when I say 15 percentile, it's the speed where 85% of people or population is taken care of or have 2 feet per second, which is the 15 percentile, or more. And these are the two values that we're going to be using a lot when we talk about people. Again, we're talking now here about people. We're talking here about the road user. So I'm going to start here with the road user. So let's get back here now. So the driver and pedestrians. Before we talked about this, we talked about when we design our system, is that we have a problem as transportation engineer, is that we have what we call diversity, different kind of drivers, mixture of drivers with different attitudes and experience and knowledge and attitudes. So no two drivers are the same. If they were computers like we're trying to do right now, like autonomous vehicles, then it will be very easy for us to design the roads. The car will know where to drive, what's the speed, and it will work very well. But we're talking about people, and in this case, we need to use human factors, like what we talked about, everything related to humans, the characteristics of humans, and usually, I'm not going to say it's all the time, it follows this kind that we draw there, the normal distribution. For example, we talked about walking speed, the driver reaction time. We calculate, number one, the value of the average, something in the middle. And also we like to usually calculate the 15th percentile, which is the value here, or the 80th percentile, which is also the value there. So our task as transportation engineers, you want to design a very safe, and that's number one here. You want safe things. You don't want to design something where people will make crashes and die or get injured. We want also an efficient, meaning that people will go to their destination fast, easy, and comfy as much as we can. For the drivers and also for people crossing the road. So we're not only talking about drivers. When we have a transportation system, we talk about the drivers and we also talk about pedestrians. So we want to find ways to provide drivers with information in a clear, effective. Information is not only by messages or radio or signs. Information just by looking at the road, looking at the curve, looking at the signs, seeing the markings, seeing the cars ahead of you. That's the meaning of the word information. Knowing that there's a problem I need to stop, or a problem I need to divert. So this is what we call here by information. In a clear, effective manner that includes safe and proper responses. So you want here the driver to see something ahead of time and react enough to either change lanes or stop. And when he goes on a curve with a specific speed, we don't want this curve to be blocked by something, so he cannot see that there is a deer there or there is a crash, and he suddenly finds it in front of him, he cannot stop, and he hits it. So we want to make the curve, we want to make turns, we want to make grades, we want to make everything related to the road very, very safe. You're going to find also that at the intersections. When we give a red signal, we're sure that we give a safe indication to the driver that you have to stop. If you go, you're going to get it. And when we give him green, it's another indication that you can go safely with the speed that we told you about, the speed limit, and it will be safe for you. So in addition, some other factors might come into account, but we don't depend on it that much. So we mainly depend on the human eye, what he can see, what he can read. But sometimes we have what we call here hearing, psychology of the driver. Sometimes it is also used when we design the highway. An example for psychology. You're going to notice that even when we drive in states or in areas where we have very level conditions, we don't have any problems with drivers seeing miles ahead of them. But still you're going to find the designer designing the road with turns. Well, his process that he said the psychology of the driver, if you keep driving on a straight line for a long time, for miles, drivers will get asleep and they might crash. Having a turn will wake the driver up, and this is part of the psychology of the driver. So again, sometimes the psychology of the driver enters into account. So the visual characteristics of the drivers, again, we're going to talk a little bit about the driver eye. These are the different, you can say, characteristics of the driver eye. Number one, what we call here the acuity, which where you focus, you can read. It's the ability to see objects in detail. It's used to read whatever, a book, sign. So when you're driving, you want to read whatever, you see the marking on the road. This is called visual acuity. Peripheral vision is what you see on the side. and it's not a very clear vision to see, but it gives you an indication of what's around. So it's detecting objects on the side. Sometimes you just can detect something coming from the side without reading it. Also, color is important, especially when we do signs. So color discrimination, and some people have problem with that, and we try to pick up colors that will make sure that it's good for everyone. Glare, it's a very crazy and important part when we drive at night, and that's why highway designers have ways to decrease the amount of glare. Imagine people driving with their high beams on all the time. You get some kind of blinded for a few seconds. Finally, we have here, and this is very important to judge when you want to stop, is what we call here depth perception. These are all different characteristics of the human eye that we use when we drive. So when we talk here about, we're going to talk a little bit here about medicine. So this is how the human eye sees. So again, we have here some kind of cones of seeing. This is how I call it. This is the first cone here between 3 and 5 degrees is where you can read. But you can still fairly clearly see between 10 to 12. We try at this cone to put where the signs are so you can read that without moving the eye away. And that's important because you want to still make the driver look ahead of you. And there's what we call here peripheral vision. It's between 120 degrees and 180 degrees. It's a cone that has this angle of 180 degrees, 120 to 180. The problem with the peripheral vision, even though it's so important, is that once you drive faster, this cone gets narrower. You rarely can see what's on the side because you're focusing on the driving task, you're focusing on that cone. So when we design the highway signs, we want it within this kind of fairly clear range of driver's line of sight. We want to read well away from drivers, we want big letters and big numbers. And we use here exactly what doctors use here, is that we want to find somebody called the design driver. The design driver is the driver. Again, it's kind of the average driver. We don't use a driver who has the best eyesight. And this driver is a driver that doesn't have the best 20/20 vision. He has a little bit less. And we compare it to the guy who has a 20/20 vision. So we call here the visual acuity based on this design driver. So let's just define as per the eye doctors. The visual acuity is a 20/20. If a person can, what does it mean by 20/20? We call it in other countries, they call it 6/6. If you can recognize a letter, let's say the letter A, that's 1/3 inch at a distance of 20 feet. This is how the doctors see that. If you have a guy with not a 20/20, you have this 20/x, so the person can recognize the letters at a distance 20/x times the distance required by the person with 20/20. So again, this is the kind of the eye doctor definition of a 20/20 driver. Let's just solve some questions which are so simple here. So a driver with a 20/20 vision can read a sign from a distance of 90 feet. Then we just use here ratios to figure out how close a person with a worse vision, 20/50, in order to read the same sign. So to do that, let's just do the question here. So again, if I have a driver who is 20/20, this is how we solve the question. We have a driver who is 20/20, can read a sign of 90 feet. Then if a driver is 20/50 vision, meaning that you have here 20/50, then how much is x? How much feet can this guy drive? So we do here a simple ratio. So my x here is equal to these two together. So it's 20/50 times 90 divided by 20/20. So here this guy goes to that guy. So it's equal 90 times 20/50. 20, so it's 180 divided by 5. And this gives me the value of the distance of the driver. So it's going to 4, right? So again, it's equal to 36. I have to use the calculator. Sometimes when you're teaching, you kind of forget math. So again, here it's 36 feet. So this driver, sometimes we call this the design driver. And usually the question tells me what's the eyesight of the design driver. It can tell me here that he would need to see 36 feet to see the sign. And this is where we place our signs. Let's do another question. A 20/50 vision person must be at